Now, actually in our initialize method, let's make sure that the ground tiles list is empty. Calling the clear method. I'm actually wondering, do we even need this initialize method? I guess we kind of do, because when we start the game, let me just go back into the original game here and refresh the page. When we start the game, we can't yet see the ground. We may not want to replicate this, but maybe we do. So I don't know. I'd say that as soon as we press a button, we would then call the initialize method so that the ground is drawn then. And before that, the ground is not actually visible. So yeah, let's keep it like this for now. And okay, let's see. I guess. Hold on. If we go back into the game and restart, obviously the movement of the ground tiles depends on the speed of the T-Rex. So the faster the T-Rex runs, the faster the ground tiles need to move. So we need to reference the T-Rex here in our GroundManager. So let's add a field of type T-Rex. And in our constructor, add a new argument of type T-Rex as well. Then initialize the field using the argument that we were passed, like this. And let's go into our update method. And then let's iterate over the list of ground tiles. Let's just call it GT in ground tiles. So we iterate over the list of ground tiles that are currently in the game. We say GT position X minus T-Rex speed multiplied by the total number of seconds that have passed between frames. So we will assume, or we will define, that the speed of the T-Rex is measured in pixels per unit, in pixels per second. So we simply subtract the current speed multiplied by the number of seconds that have passed from the X position of the ground tile. And for testing purposes, let's go into the T-Rex class and initialize its speed with, I don't know, 20 pixels per second. Start up the game, and now it should slowly, whoops, no. Oh yeah, we need to pass the T-Rex here to the constructor in our game class. But now let's test it, and the ground should now slowly move to the left. Very slowly, because 20 is not enough. Let's say 200. And there's something wrong. Let's go back into the GroundManager. Or maybe the ground tile. What's wrong here? Oh, right. In our game class here, we forgot to actually add the GroundManager to our entities. Whoops. There we go. And that's the reason why the update method wasn't called. So maybe let's go back to 20 is a little bit low. Let's say 50 pixels per second. Now let's start up again and it should slowly move to the left. Yeah, it does. Great. Okay, but obviously now the ground kind of just ends here. We need to spawn new tiles as we go along. So let's go ahead. Here. So now here we could check if the current X position of the tile is less than negative sprite width. Because that would mean that it's completely off screen. We've moved it so far to the left that it is completely off screen. If well, let's say this, we have our sprite here. Say this rectangle is the sprite, the ground tile. So now it would be at position 0, and we move it and move it and move it and move it, and when it is completely off screen, when it's here, that would mean its position is exactly the negative width. So let's go back into the code, and as soon as that condition is met, we would then remove it, and we can do that using the entity manager and just say remove entity and pass the ground tile. But then we also need to make sure that it is also removed from the list of ground tiles here in our ground manager. And remember, we can't just here go ground tiles remove and pass it there, because we're currently iterating over the ground tiles collection, so we shouldn't do that. Instead, let's put a list here, a local variable of type list, list of ground tiles, and call it tiles to remove. Will be a new list, and then here we simply add the tile to our list of tiles to remove, and then after iterating over all the tiles, we will simply go for each ground tile GT in tiles to remove, ground tiles remove GT. So we iterate over all the tiles, move them slightly to the left according to the speed. If it's off screen, we remove it using the entity manager, and we also put it into this list of tiles that need to be removed. And after iterating over all the tiles, we again iterate over this other list of tiles, the ones that we said should be removed, and then simply remove them from the list of ground tiles. So that's fine. But we also need to spawn new tiles. So let's do that. And for that, first of all, we need an instance of random. in order to randomly determine if it's a regular tile or a bumpy tile. And in our constructor, create an instance of random, assign it to the field. And now, let's see. Let's go here, up here, and say if ground tiles any, which is in a different namespace. It's in system link. Any is an extension method from the link namespace, and it returns true if there are any elements in the collection. So if there are any ground tiles, and whoops, then we get the maximum X position of all of the ground tiles. And if that maximum X position is less than the sprite width, then we need to spawn a new tile, because that would mean, oh no, actually, if it's less than 0, sorry, because that would mean, if we again pretend that this rectangle here is our sprite, our tile here, this is the screen. So now it's at position 0, and the moment it goes into the negative, there would be, whoops, there would be an empty space here. So this would be the moment that we would have to spawn a new tile as soon as the position goes into the negative, as soon as it has a negative X position. So let's go back into the code here. So if the greatest, we get the greatest, the maximum X position from all of the tiles that are currently spawned. And if that is negative, we need to spawn a new tile. So let's create a method here, a private method. It will return, no, actually it doesn't need to return anything. Private void, and call it spawn tile. And we will pass the maximum X position. No, actually, we don't need to do that. Spawn tile. And let's use our random instance, our instance of the random class, to determine whether it's a bumpy or regular tile. And we can simply do that by saying something like this. Whoops. Actually, let's make the local variable of type double, so we don't need to cast. We will generate a random double, which will give us a double value, a decimal value between 0 and 1. And then we say if the random number, actually declare a new variable called ground tile. Then if the random number is larger than 0.5, the ground tile will be, we will call the create bumpy tile method. Right, we need to pass the position. Let's go ahead, create another local variable, call it posX, And the new position of the newly spawned tile should be the maximum position of all of the current ground tiles. Plus the sprite width, right? So if we get of all of the currently spawned tiles, get the highest X position and add the width of one sprite, we should get, that should give us the target X position of the new tile. Then we can pass it here. And then say else, whoops, keep messing up, else ground tile equals create regular tile, and also pass the posX float value here. Whoops, there we go. And well, let's actually make this here. Let's add a argument here and call it a max posX as I suggested earlier. And then we will here simply do this. And lastly, we need to use the entity manager to actually spawn the ground tile and add it to our list of ground tiles like this. And here now, if I go back to our update method here, let me actually do it like this. Whoops. There. Like this. And the only reason that I do this is that if someone was to call the spawn tile method without checking first if there are any tiles in the ground tiles list, and we would then call the max method without there being any elements in the list, it would throw an exception. And since I already covered this case here by calling the any method first, this problem would be solved. So in that case here, we just get the maximum position, X position, and then just pass it here because we have already called the max method, and we don't need to call it again here in the spawn tile method. But that's just optimization. It doesn't really matter. It's not that big of a deal. But anyway, so yeah, that should do the trick. Yeah, I guess that's already fine. Let's check. Let's start the game. See? Now it's no longer just suddenly ending. And it actually spawned a bumpy tile. Let's actually increase the speed a little bit so we don't have to wait an eternity to see it. There we go. Let's jump. Yeah. Seems to be working perfectly fine. That's great. And it completely depends on the speed of the T-Rex. So if I put this to 500, then it should move really fast. Right. And it looks great. Perfect. All right, so what I want to do next is, first of all, make sure that the T-Rex sprite is always drawn on top of the ground sprites. And remember, we that's what the draw order property of our game entity interface is for. So we can simply go ahead and here, after initializing the T-Rex, we can set its draw order to something like, I don't know, 10. So that way it will always be drawn on top of everything else that has a draw order lower than 10. And since in the GroundManager we do not specifically set the draw order of the ground tiles, it will be, by default, it will be 0, so it's less than 10 obviously, so it will be drawn behind the T-Rex character, basically, behind the T-Rex sprite. And yeah, what I actually wanted to do here is, let's go back into the T-Rex runner game class. And what I want to do is, if we take a look at the original game, basically our game does not directly start. It's in this initial state here, basically, and as soon as I hit the jump button, the T-Rex character performs a full jump, which I cannot cancel. And then it fades in the background and the floor, the ground tiles, basically, like this. And after that, the game actually starts. So before that, I cannot crouch or anything. Let me just load this up again here. I cannot crouch or anything. I have to press the jump button in order to start the game. Wait, hold on. Yeah, I have to press the jump button to actually start the game. Then the background will fade in, and then we're actually able to control the character, and the game actually starts. So yeah, how can we achieve that? Well, first of all, we should maybe define the states of our game. So basically, I think there's 4 states of the game. If we load this up again here, this would be the initial state where nothing's going on except this little T-Rex sprite that sometimes blinks. And then as soon as we hit the jump button, we shortly change into a transition phase where we slowly fade in the background and make the character jump. And then after that, we're in this playing state, basically. And as soon as we run into an obstacle, the game changes into this game over state. So we basically have 4 game states that we need to model. So let's go ahead and do that using an enum type. I will just define it up here and then move it into a separate file afterwards. Let's call it game state. And the states will be initial, transition maybe, for the little fade in animation, then playing, and game over. Something like this. Then I'm going to right click, name, quick actions, move type to game state CS, and then it is automatically moved into a separate file. Now let's go back into the game class and let's see. First of all, let's add a property with a private setter of type game state that stores the current state of the game. And just to be thorough, in our constructor, we're going to set the game state to initial, even though we don't really need to do that. Now, what else? Yeah, before the game starts, we're not actually able to control the character. So let's make sure that we can only use the input controller. The controls are only processed if the game is in the playing state. So let's go ahead, if state equals playing. Then we want to process the controls using the input controller. Otherwise, we're just going to completely ignore it. Okay, so what next? We need to somehow implement this little fade-in animation here. Let me just refresh this here. As soon as we press the jump button, the background and everything else is slowly fade in. Or actually rather quickly, but it is a fluid animation. It does not just pop up out of nowhere. And what we can basically do here is, let me go into my photo filter here. And I actually, between cuts, I actually quickly prepared this. So what we could do here, if this is our game screen, is we could simply render a white texture, like a large giant box, over everything that we don't want to render yet, or that we don't want to be displayed yet. And then when the game starts, we can just simply slowly move it to the side to create this little effect of the background slowly fading in. Like that. I think that'd be a good approach. So for that, we need a texture. Basically, what we just need is a white texture, and the size doesn't matter. It can be a 1x1 pixel texture. And we don't need to import it as an asset or something like that. We can simply generate it programmatically. And for that, I'm going to add a new field of type texture 2D, sorry, and name it fade in texture, something like that. And then in our load content method here, maybe after the sprite sheet texture was loaded, we're going to generate a texture and store it in our fade in texture field. We can do that like this. Pass the graphics device to the constructor and then the dimensions 1x1. So simply call the texture 2D constructor, pass the graphics device from our graphics device property, and then the width and the height, which will both be 1, and we will just simply basically stretch it over the screen. And then we also need to set the data, the color values of the texture, and we can do that using the set data method. And here we can simply pass an array of colors, and since it's just 1 pixel, we can pass an array that consists of a single element, which is the color white, like this. So now we just this way we can generate a texture that is 1x1 pixels, and this pixel is going to be white. So very, very simple. And this texture will then be stored in memory in form of a field. Yeah. So far, so good. So if we start up our game now, we should actually not be able to control the character. So I'm pressing down, the down arrow key, spacebar, nothing happens. And that's because in our update method we checked the current state and only call the process controls method of the input controller if the state is playing, which it is not. So yeah, we now need to make it possible to actually start the game. And there's another thing I want to do. As you can see here, when I start the game, the floor, the ground is already moving rather rapidly, and obviously we only did that for testing purposes. So let's remove that. So let's here, instead of initializing the speed property of the T-Rex with 500, let's just remove the initialization here so that it will be 0. And if I start it up again, now the floor should be completely frozen in place, so to speak. Yeah, looking good. Now, of course, we need to be able to start the game. So let's go back into the T-Rex Runner game class. And maybe here we could do something like, let's implement a new method called start game. And maybe make it return a Boolean if the state is initial, or if the state is not initial, we won't do anything and simply return false. And otherwise, we will first put the game, put the game into the transition state. Then what else? Oh yeah, we need to render our generated texture, or fade-in texture. Let me format that a little better. There we go. We need to render this actually, but only when it's in initial or transition state. And we need to position it as well, and then slowly move it to the side. So let's say fade in texture pos x to store the position. Oh, fade, not face. And in the constructor, I will initialize that field with the width of the T-Rex sprite, because that should give me the correct target position, the X component that is of the position. Because let me so let's say, or let's open this up here. So this is our white texture here, and it starts exactly where, obviously, so the position is basically the same as the width of the sprite here. So that's what we're going to do. So in the constructor, set the position to the sprite width. That's fine. And then in our draw method, we can go here and say if state equals initial or state equals transition. Then we can do something like sprite batch, draw, fade in texture, and then the destination rectangle would be the bounce on the screen where we want the texture to be drawn. So we can just stretch it. And here we can pass a new instance of rectangle. And the X position will be the one I just defined as a field. Then the Y position will be simply 0. The width, I can just use the screen width, for example, the window width, and the height will be the window height. And oh yeah, the constructor of rectangle takes 4 integers. The X position here is of type float, so we need to cast it. And actually what I'm going to do is round it to the next integer and then cast that value to an integer like this. And there's one argument missing, which is the tint color, which would be white. Okay, now what else? Oh yeah, in the update method, if, let's go here and say else if state equals transition. So only in the transition state we want to slowly update the position of this texture. So we will increase it by the game time, elapsed game time, total second, and now basically the speed in pixels per second. I don't know. Let's say 500 for now, for testing purposes. And we should cast this to a float, sorry, since this is a double. Here, return true. And now we need to call this start game method at some point. There's another thing that we want to do in the start game method. We not only do we want to start this transition animation, we also want to make the T-Rex jump. So call the begin jump method of the T-Rex class, of this T-Rex field. And that's fine. But we still need to call this start game method somewhere. And it should be called after a button press, after either the space bar or the up key is pressed. So yeah, let's go add a new field of type keyboard state and call it similar to our implementation in the input controller. Create a field named previous keyboard state, which stores the keyboard state as it was in the previous frame. Then here in our update method at the very end, say no, first we need to, before we do anything, let's say here, get the current keyboard state like this. And then here at the end of the update method, we will assign the current keyboard state to the previous keyboard state field. And yeah, now let's say here else if state equals initial. If it's an initial state, Then what we want to do is check the keyboard state. If the up key is pressed or spacebar is pressed, and let's actually put this in a local variable. Is start key pressed? Duplicate it. Was start key pressed? Previous. Very similar to what we did in the input controller for jumping. Now here, if is start key pressed, whoops, if is start key pressed and it was not pressed previously, then what we want to do is call the start game method. That should do the trick. So now, if we create an instance of this class, of this T-Rex Runner game class, the state is first set to initial, which will be checked here in the update method. And if it is in state initial, we will check the input. And if either the up key or the space key is pressed, then we call the start game method. And then in our start game method, we, in this case, redundantly check if the state is initial. If not, we won't do anything, because starting the game is only possible in the initial state of the game. Then set the game state to transition. Call the begin jump method to make the character jump, and simply return true. And since then our game is in the transition state, in the next call of the update method, we check that here, if it's in transition state, and if so, we slowly increase the position of the texture. And in our draw method, we check if it's an initial or transition state, and if so, we draw the texture at the appropriate position. So let's test that. I'm going to go ahead and press space. Looks great. But it's a little bit too slow, I think. So let's say maybe 800. Start the game again, press jump. Looks great. I think it could be even slightly faster. Let's say 820. Start up the game again. Yeah, perfect. And I will store this in a constant by right-clicking it and selecting introduce constant for 820f. And I will say here fade in animation speed. Something like that. Whoops. There we go. Let me start it up again. Yeah, there we go. And I should not be able to actually cancel the first initial jump. And yeah, it works like a charm. Perfect.